The 1985 Japan airline plane crash shocked the world. Did you know that NIMS found the cause? A sodium leak at the Monju nuclear power plant. The H-2 satellite launch system crash. Whenever a serious accident occurs, NIMS steps in to play a key role in finding the cause, to ensure that it never happens again. We start by examining wreckage taken from the scene. From faint trace evidence, we try to find out what happened and identify the technical pitfalls that led to the accident. We use our metal materials expertise to ensure safety. In Japan, the causes of many accidents are not immediately apparent. We have to solve these mysteries in order to prevent these serious accidents from happening again. When the police and the Japan Transport Safety Board request our help, we investigate the wreckage and we use our collective knowledge to find the cause. First of all, we take a comprehensive look at the wreckage and narrow down possible phenomena that could be responsible. We inspected fractured surfaces especially thoroughly because they contain a lot of information. For example, this fracture surface is partially flat. This is caused by a fatigue failure. Note the dynamic distortion of this irregular section. We surmise it was torn off by a sudden overload. The next step is to prepare a specimen for inspection by our electron microscope, so that we can look for characteristic patterns and microstructures on the metal surface that can suggest the cause of the breakage. In 2002, we were requested to investigate a motorized glider accident, in which the glider's propeller suddenly broke away. The plane barely managed to glide to a safe landing. Dr. Furuya, the lead investigator on the case, started by visually inspecting the bolts that were used to secure the propeller. All 6 bolts were broken. Their fracture surfaces showed a similar pattern. This pattern could not have been created by the sequential breakage of the individual bolts. Thus, it is reasonable to surmise that all 6 bolts broke simultaneously. Further inspection using an electron microscope revealed that nearly half of the break in each of the bolt is a fatigue crack that developed over time, while the remainder of the break was a sudden failure under a heavy load. In other words, the fatigue cracks developed gradually as the propeller rotated, until the bolts reached their breaking point. Dr. Furuya still had an unanswered question, however. Generally, a propeller and its rotating hub are bolted directly together in unbroken contact with one another. This tight fit prevents rotational stress from affecting the bolts. What caused these 6 bolts to all fracture simultaneously? Later, he noticed a critical mistake when some parts were replaced 1.5 months before the accident. A rubber ring was mistakenly placed between the propeller and the hub before the propeller was put on. This introduced a gap between the propeller and the rotating hub and allowed all of the rotational force to be concentrated on the 6 bolts. Dr. Furuya's deduction that all 6 bolts broke at the same time under heavy load revealed the true cause of the accident. After the 1985 Japan Airlines plane crash, NIMS discovered that the rear pressure bulkhead had failed due to metal fatigue. Material sleuths from NIMS also helped solve the riddle of the 1995 sodium leak and found out why a rocket crashed into the Pacific Ocean in 1999. NIMS played an important part in finding the causes of all of these accidents, contributing many improvements that have prevented them from recurring.